Hello and welcome to our equation solving unit. We are now on the section of 3.4, variables on both sides. So we're going to be solving equations that have an unknown both on the left-hand side of the equal sign and on the right-hand side. Make sure that you add in your name and date to this, so please add in your name and date, along with the pizzazz page numbers that go along with variables on both sides. We often call this VOBS, V-O-B-S, as the acronym. So that's just something extra you can add in there. And the pizzazz pages are 41 and 42. Let's go ahead and take a look at some vocab, some rules to follow for equation solving that we've already discussed in previous note sheets. So let's add in the title of rules to follow for equation solving. And our first to add is to simplify each side of the equation. So make sure that you add in simplify each side of the equation. Essentially, we're looking to combine like terms. So the CLT stands for combine like terms. So, and remember, we're looking at each side of the equal sign. We're not combining terms across the equal sign. So you got to do the left side, simplify if you can, the right side, simplify if you can, and move from there. The next thing to remember for rules to follow is to balance the equation. So when we talk about balancing the equation, we're looking to apply operations to both sides of the equal sign. So if we add 3 to one side, we need to add 3 to the other. If we multiply by 4/3 on one side, we need to multiply by 4/3 on the other side. So balance the equation by applying the operations to both sides of that equal sign. The last thing to be aware of is to solve by isolating the variable. And we talk about isolating as a way to get everything else away from that variable. It's all alone. And a reminder for VOBS. So VOBS stands for variables on both sides. So when we talk about this is a VOBS equation, that means that we have multiple variables and it's not a simplifying situation because they're on separate sides of that equal sign. So we're going to move to the method for solving equations that have variables on both sides. Now this is a 4-step method. The first step is to simplify each side if possible. Now again, when I talk about simplifying each side, I'm talking about combining like terms. And so if I get to that stage, I still am only combining terms that are like on the left side and terms that are like on the right side. I'm not putting them together across that equal sign. So we separate these guys. We've been doing a great job with that so far. So we're going to move ahead to the step 2 that says move the variable term to the left side. And we move this variable term by adding or subtracting. Just like we would move a constant from one side to the other, where we would be adding or subtracting it, we're going to move the whole term by adding or subtracting that whole term. And we're going to want to move it to the left side because we're really comfortable with having our answers in x equals form or in y equals form. So we like the variable to be on the left. Our third step is going to be to finish solving. And we're going to want to finish solving using steps from our 2-step equation because we've already gone through the idea of combining terms and simplifying. And now we've moved that variable, so we now essentially have created a two-step equation. So see the notes from 3.2 on the ideas of the steps of how to do that. Our last step in the method for solving equations with variables on both sides includes step 4, which is the check. And we check a solution by rewriting the original equation. The next item is to substitute that solution back into the original equation. Once we've substituted the solution into the original equation, we're going to want to solve using the order of operations. So we are only simplifying using order of operations. We are not solving this again. We shouldn't be moving terms from different sides of the equal sign. And we're going to go ahead and do our first example. So let me go ahead and write this in. So example number 1 says 3x plus 2 is equal to 4x minus 9. Now this is in fact a variables on both sides, as we have a 3x on the left-hand side and a 4x on the right-hand side. So we do have a variables on both sides. And in order to make this a little bit easier for us to work with, I really like the idea of making a little kind of river, if you will, down the equal sign. So I know that if I move things from one side of this river to the next, I have to be adding and subtracting them. I can't just combine the terms. So I take a look at this and I say, on this side, I can't combine 3x and a 2. They're not like. And over here, I can't combine 4x and negative 9 because they're also not like. So I get to go ahead and move this variable to the left side. So this variable here needs to go away. And in order to get rid of it on that side, I'm going to either add it or subtract it. Now I have a positive 4x. So that's telling me I want to subtract 4x from both sides. So that cancels out and I am left with a negative x plus 2 is equal to negative 9. Now we can work here using our two-step equation solving skills of subtracting 2 from both sides. And that's going to give me negative 1x is equal to a negative 11. Now I'm going to move that negative 11 over as it looks like it's shifting, and I want to make sure that we are aware that it's on this side of that river, if you will. And so this is going to then tell me that I need to divide both sides by negative 1. Whoops. And let's go ahead and actually move this over. So if I go ahead and divide both sides by that negative 1, I'm going to find that x is equal to a positive 11. And we're going to go ahead and check this answer of 11 back into our original equation. So I'm going to write out 3x plus 2 is equal to 4x minus 9. And then I'm going to write out 3 times 11, because I believe x is 11, plus 2 is equal to 4 times 11, again because I believe x is 11, and subtract 9. So here I'm using order of operations from now on, and I'm going to have to multiply before I add. So this 3 times 11 is 33 plus 2, and 4 times 11 is 44 minus 9. From here I'm going to find that I get 35 equals 35, and in fact I have checked my answer. So x is in fact equal to 11. I'm going to go ahead and box that in. We're going to do another example, so please flip over your page and we're going to add in the section title. Again, we are working on 3.4. So please add in the section title of 3.4 variables on both sides. So you can shorthand that if you'd like to write VOBS. VOBS. It's a nice acronym. And we're going to do example number 2. The second example is 17 minus 3x is equal to 6x minus 4 minus 2x. Now again, my first idea that I'm working with is to simplify each side if possible. So I'm going to look over here and say, I can't simplify that. And over here and say, hey, I think I can combine some terms on this side. So we're going to notice that we can combine the 6x and the negative 2x together. And again, I write on that squiggly line for like the river to say, hey, I can't move terms without adding or subtracting between those sides. So I'm going to have 17 minus 3x, so that's going to stay. And because I have this 6x and the negative 2x, that provides me with a 4x minus 4. So we've simplified, we've gone through the first step of making it easier on each side of the equation. Now we're going to go ahead and move the x term onto the left-hand side. So we're going to subtract 4x from both sides and find out that they cancel on the right, leaving us with 17 minus 7x is equal to negative 4. From here, I'm going to try and isolate x. So I need to get rid of everything near the x. So first, we are talking about a two-step equation. And that means I need to get rid of the term being added or subtracted. So let's get rid of the positive 17. So subtracting 17 on both sides. I get negative 7x is equal to negative 21. Now from here, I can divide both sides by negative 7. Don't drop your negatives, please. And I get a positive x is equal to a positive 3. We're going to check this answer, so we're going to rewrite it. The original equation of 17 minus 3x equal to 6x minus 4 minus 2x. Everywhere I see x, I leave parentheses involved because I'm going to place a 3 where I had an x in that original equation. So I'm going to have 17 minus 3 times 3 is equal to 6 times 3 minus 4 minus 2 times 3. This gives me 17 minus 9 is equal to 18 minus 4 minus 6. So simplifying, 17 minus 9 gives me 8. And 18 minus 4 minus 6 gives me 14 minus 6, which is 8. 8 equals 8, so I get to check my answer, double checks, and I get a box in x equals to 3. Now I have another example for us, and then we have a try on our own to go from here. So this provides us with our last example of guided notes. And we're going to have the idea of 20 plus 5. So let's write example 3. 20 plus 5x equals 4 minus x plus 20. Oh, excuse me, pardon me. Plus 10. So let's re-say this. This problem says 20 plus 5x is equal to 4 minus x plus 10. Awesome. So we do have a couple of things that we can combine on both sides. I'm going to draw a little river so I know where I'm headed. And I can take the 4 and the positive 10 and put those together and get 14. So let's simplify and get 20 plus 5x equals. So that side stayed the same. And I get minus x plus 14. Here I want to move the x term from the right-hand side, this guy, over to the left. So in order to move a negative x, I want to add x to both sides. That allows me to cancel this x right here. and I'll only have 14 left over on that side. So my new equation I'm working with is 20 plus 6x is equal to 14. And from here, I have a two-step equation, so I'm going to subtract 20 from both sides and get 6x is equal to negative 6. When I divide 6 on both sides, I'll find out that x is equal to negative 1. And we're going to go ahead and check it. So we're going to rewrite the original equation of 20 plus 5x equals 4 minus x plus 10. And I have the idea of 20 plus 5x, where x is now negative 1, equals 4 minus negative 1 plus 10. So everywhere I had that, I'm going to plug in that negative 1. And that moved a little fast, so let's back it up. And 5 times negative 1 is negative 5 for sure. And minusing a negative 1 gives me a positive 1. So that's where I'm at here. And from here, I get a positive 15. And from here, I get to take a look and I have 5 plus 10. And 5 plus 10, in fact, is 15. So I know that x equal to negative 1 is the correct answer. We now checked it out, and we did an excellent job there. Let's go ahead and you're going to try two equations on your own. So if you don't have space on this side, that's absolutely fine. Grab the back sheet, I believe has space. And these are the try on your owns. You don't have to label them if you don't want to, but I do want to make sure that you check your work. Now again, it's the attempt that's important, and it's nice to be able to try this on your own. So our first problem for you to try on your own is 8x is equal to 3x plus 35. Now again, we do have a variable on both sides. We have the 8x on the left and the 3x on the right-hand side. So make sure that you draw a river if you're getting confused as to which side is which, and go ahead and solve, following the steps. So remember, our first step is to simplify each side if possible. 2 is to move the variable term from the right-hand side to the left by adding or subtracting. The third is to finish solving using the two-step equations. And fourth step is to check the solution. All right, so we are going to have you start on 8x equals 3x plus 35. And the fifth example that is also a try on your own is 63 minus x is equal to 2x plus 3. And here we do also have a variable on both sides. So make sure that you follow the steps and check your answer. A good, genuine attempt will give you full credit on your homework. Thanks for listening. We'll see you in class tomorrow.